Okay, I told you I would show you some demos for magnetic forces. Remember, the key thing is that if we have a moving charge in a magnetic field, then there's a force. And the best way to have a moving charge is with electric current. So here I have a wire, and it can kind of swing a little bit, you see? And I'm going to hold it, there we go. I'm going to hold it over this magnet right here that you can't see because that wire's in the way. Let's move that wire. Okay, there we go. Now it's swinging a little bit better. And let's see what happens when I connect it to the battery. Do it again. So you can see that the force on the wire is perpendicular to both the magnetic field and the current. So this is a good example of a force on a wire. Okay, let's move that out of the way. I'm just going to drop it on the ground. Let me go ahead and show you my next demonstration of the magnetic field due to a wire. So here's a magnetic compass, and I don't know if you can see this okay, but maybe you can. Oh, I need my wire down here. I threw it away. Okay, let's get this wire. And what I'm going to do is to hold the wire over, I'm going to move my magnet out of the way, over the compass, just like that. So you can see the needle. Hopefully you can see that needle. Now I'm going to connect with my own hands, having trouble here. Let's bring that 9-volt battery back. Because I can clip it. Okay, so here I have a current right there coming out, and I'm going to put this directly over the compass, and I'm going to touch it right here. Watch the compass needle. So you see that the magnetic field due to the wire the current in the wire creates a magnetic field going that way. Then this shows the sum of the directions, both the magnetic field due to the wire and the earth, and so it bends that way. Now, remember it bent that way. What happens if I put this on top? It goes the other way. So this shows the circular nature of the magnetic field due to a wire. Now, one more thing. If I put the wire over the compass like this, so they're already perpendicular, the needle won't move because this will make a magnetic field in the same direction, and so they just doesn't change the direction. Okay, let's do an electric motor. This is the simplest electric motor that you can make. No, it's not. I'm going to show you a simpler one. So here I have a battery, and then I have this holder right here, and this is magnet wire. So magnet wire is used to make electromagnets because it has enamel on the coating. So that enamel prevents the current from just taking the shortest path, and it forces into this loop. So if I run a current through there, it's going to make a magnetic field, and that can interact with another magnet. Let me go ahead and get this running, and then we can talk about the other trick to get this to work. So I'm going to balance this on here. It's not a very good motor. It's just a very simple motor. There's a difference, right? So you can see there that it's already moving. I'm going to just give it a little flip to get it started. So I have a magnetic field, and then I have a coil of wire, and they interact, and that exerts a torque. Now, if I didn't do anything, this would rotate and stop. So the trick here is to shave off, and you probably can't even see it, shave off the enamel on the bottom parts of the wire here and on there. So when it sits like this, it makes electrical contact, and there is a current, and then that exerts a torque, and it rotates over. But then it gets on top of the enamel, and there's no more current, so its angular momentum just keeps it rotating around until it gets another boost. So you have to have some way to switch the current. In this case, I'm just turning the current on and off. Let me show you the simplest motor. I said that was the simplest motor, and I lied. The simplest motor is this. Here's a magnet. I feel like my camera angle's bad, and I should redo this. So I have here a screw on my magnet, and I'm going to let that stick and hang on the bottom of this. I had another wire. Where'd my other one? There it is. Right there. Now I'm going to take my wire and run it from the top of the battery to the side of the magnet. Now, this magnet is also an electrical conductor, so I'll make an electric current that goes up through the magnet, through the screw, and then back to the battery. Let's watch what happens. I'm going to touch over here. Wait, I don't want it to swing. So we get, this is actually called a homopolar motor because it only has one pole, homopolar, right? So what happens is the electric current comes down here, and then on the top of the magnet, it runs across the top. There's a magnetic field going up, and it pushes that current to the side, but then because the resistance increases, that causes the whole thing to want to take a shorter path, and so it turns the whole magnet and exerts a torque and makes it rotate. You can get it going really fast. It's kind of cool. Okay, put the magnet over here. I do want to show you, oh, another magnet. Okay, this is a just a normal motor. I was going to turn it on, but I don't really care. This is not a normal motor, okay? So you'll notice that, actually this one might be. But a lot of these little computer fans like this are not normal DC motors. They have different poles, and they change the current through the different things. So you have to have a driver circuit to drive these. This one actually might be just a normal motor. Actually, I'm not even sure. Let's just try plug it in and see what happens. Most of the computer fans are not, though. Yeah, nothing. Okay. So you have to have a driver circuit to drive these. Now I want to show you this, because this is another electromagnetic force thing that everybody uses. Do you know what this is? This is a relay. So a relay is a couple of things. This is right here is an electromagnet, and when you run current through that, it's going to pull this little plate. See the little plate right there? And that's going to change these contacts down here. So what you can do is by running current through this, you can turn this switch. It turns into a mechanical switch that turns on and off with electric current. So you hear that noise? So in your oven, let's say, is a good example. When the oven gets to the right temperature and it turns off, the thermostat turns off the element, well, it uses a relay, and you can hear it going click. And then when it comes back on, click, click, click. So it's just an electromagnet. Here's another one that you can see a little bit better. I arranged this, I wired this one up so that I could do something cool with it, which I'll show you later. Actually, I made this into a buzzer. So what I did was I have the current that runs the electromagnet operated by itself. So when it turns on, it turns itself off. So that just makes it turn on and off all the time. And I don't remember which plugs go to which, so I'm going to not plug that in right now. But that's another relay. Okay. I think I went through all the demos I wanted to get through. Hopefully that worked out okay for you.